Welcome to our PCOE GIVVCE project presentation. Our project was created for the Ohio Valley Museum of Discovery. We focused on a STEAM project, and we created 2 units. Unit 1 is Coding for Kids. Unit 2 focuses on animals and their habitats, and we created mobile exhibit discovery units. Our age levels for these projects is grades 1 through 5, so there's a wide variety of age groups. Members included Amy, Holly, Cassandra, Shook, Ren, Emily, and Nadia. So our project overview was this type of mobile exhibit as a way for children of all ages to explore different STEAM activities. STEAM stands for science, technology, engineering, art, and mathematics. So this project is intended for single workshop or day sessions. They are portable and flexible. These types of products will help to develop a variety of skills such as critical thinking, problem solving, collaboration, creativity, and innovation. So our goal was to create fun, hands-on experiences for children and to help them learn how to explore, gain knowledge, and work together. This is an excellent solution for the community needs as a way to provide on-the-go tools to help local schools, the public, and underprivileged communities. Many children lack the critical thinking skills that they need to help them cope with the 21st century innovations in technology. This project will help fill the need for creating more mobile units that can target a large number of the community. Community centers in the area can also benefit from these exhibits. The project team created a strategic plan to build 2 units at the beginning of this project to pilot and test the acceptance rate before creating more units. So the first unit that we're going to talk about is in the Coding for Kids unit. And this is unplugged coding without computers. So they're learning to code without technology, and that's a great start for learners that are not experienced with coding or using computers. So our first one is Lego secret codes. So children are learning to use Legos to figure out a hidden code. So each Lego block represents a different letter of the alphabet. And then the children are to figure out the secret code, and there are 4 separate codes that they can figure out. So they'll write each letter that represents the brick of the code, and then they can figure out that secret code. Our second activity for Coding for Kids is the BBOT activity, and this is a beginning coding, programming, and robotics. So there are 3 levels to the BBOT program. The first one is a color matching grid. So this STEAM activity focuses on science, technology, and math. Learners should play this level first. It contains 12 square grid and color flashcards. 1 square is a go square where the BBOT will start, and the other 11 squares are different colors. So learners place the BBOT on the go square, and next they pick the flashcard. Then they will use the command cards to plan how they will program the robot to move to that color square. Next, they program the robot and test out their plan. The second BBOT program is the number grid, and this STEAM activity focuses on science, technology, and math. It contains a 20 square grid with numbers 1 through 20 and counting to 20 flashcards. So the learners will pick a flashcard and count the number of objects and then put the BBOT on that number. Then they will pick another flashcard. This is the number that they will program the BBOT to travel to. They use the command cards to plan, program the robot, and then test out their plan. And BBOT City is our last project for this unit. And this STEAM activity focuses on science, technology, engineering, art, and math. It contains a 50 square grid. 25 squares are grass and 25 are roads. So the facilitators will need to provide a variety of materials for building houses. And some of the materials they can use are blocks, popsicle sticks, straws, construction paper, felt, buttons, and different materials. So learners build a house and place it on a grass square on the grid. If there are more than 25 learners, some can share squares. Houses will need to be labeled with names or a photo of the learner. Then they take turns programming the Bee-Bot to go to different houses. They will use the command cards to help them plan their coding sequence. And our next coding activity is Coding Can Be Fun. And this focuses on Lightbot, Cargobot, and Scratch, which are apps for iOS and Android. So children will learn basic programming knowledge through playing puzzle games on their iPads or tablets. Children can start playing games in 2 apps to try to figure out basic logics and patterns of the coding from easy to advanced modes. The learning process will be interactive, and children are able to get immediate and effective feedback while playing the puzzle games on mobile devices. For children with advanced coding skills, they might consider playing Scratch to create something new and share them online. And our next units start with our animals and habitats. Unit 2, animals around us. So students or children are learning about animals in fascinating ways, and this unit will help children learn about animals and their habitats. So the first activity we have is a felt project laid out with different animal habitats. We have the Arctic, we have the sea, we have the farm, forest, and the desert. So each container contains different animals that would live in those habitats. So the children would take the animals out of the container and place them in the right habitat. Our next activity is climbing gecko. So this activity introduces students to a gecko science experiment that focuses on static electricity and math. Students will learn about how different materials react towards each other while exploring time with a stopwatch. They will also learn how to make a hypothesis and educated guesses. So they'll use a balloon. They can blow it up or have someone else blow it up for them and tie it, and that will be their gecko foot. Once the balloon is blown up, the children will rub it against a wool sock or wool fabric. That's in order to create the static electricity. And they will then have the opportunity to place it on different surfaces, which we have here: cotton, nylon, a mirror, a piece of carpet, and also a piece of wood. You can rub the balloon against your hair to conduct static electricity. And once you have rubbed the balloon on the wool fabric, the students will quickly move the balloon to the surface that they first choose. They will go down the line and try each surface. The balloon should stay on the surface that will conduct the static electricity. This is where their hypothesis and educated guesses take place. If the balloon stays, the student will use their stopwatch to time how long it stays on each surface. So at this point, the students will become their own scientists and record their answers on their data sheet. And our final activity focused on polar bears. And our question was, why are polar bears white? And this explored the Arctic tundra and the animals and their adaptations. So the materials needed, we have different books that the children are going to read. So they'll start out reading and exploring polar bear books. They'll discuss their habitat and the adaptations, such as their white fur, blubber, and the temperature of their habitat. They will then cut out the polar bear printout and discuss the color of the polar bear's fur and how it's the same as the snow and the ice of their habitat. So they'll discuss the benefits of this and how it keeps them safe and allows them to sneak up on their prey. Also, it will talk about their skin underneath, that the fur is black and soaks in the ultraviolet radiation, warming them up. Then that same white fur traps the heat in close to the skin and insulates them. Then the students will place the polar bear on the white printer paper, and they will talk about how that they are camouflaged against the snow. And then also place the polar bear on the blue construction paper to demonstrate the contrast. So they'll take the white printer paper and tear it apart to make hill-like shapes, and they'll glue those shapes to the blue construction paper. They'll also place the polar bear cutout between the hills and then glue it down. And then the students will use the pastel chalks to draw an aurora borealis in the sky above their polar bear. So we hope you enjoyed our presentation for our PCOE GIVVCE project. We really enjoyed working together, learning about each other and the different projects that we created. So our team members are pictured here. We have Cassandra, Holly, Ren, Shook, Amy, Emily, and Nadia. Thank you for watching.